So, Darryl, I've just finished bonding my strain gauge, and how can I tell for sure that I've done a good job with that? How do I verify that this strain gauge is going to tell me the truth in the long run?
Well, Tom, that's a great question. And the way we like to look at it is you have to break it down into really three key categories, three things that you need to look for in trying to determine whether or not you've got a good gauge installation. And those three categories are this. The first thing that you do is you optically inspect it. So once you get the gauge installed, you take a look at it and you look for things like edges of the strain gauge that are lifted. You look for voids underneath the pattern of the gauge. You might also look to see that you got it in the right spot. You know, oftentimes when you clamp strain gauges and you put them inside of an oven, that the clamps can move and the gauge can move around. So you're really trying to optically inspect it and see if it looks good. And if it looks good, if the gauge is down nice and flat, there's no signs of voids, the gauge is in the right location, then you really move on to the next step, which would be wiring the strain gauge. And once you get the leads connected to it, you get it soldered and you get it cleaned, then the sort of the second stage of verification would be testing it electrically. And there's really two things you look for. Number one is you look for the installed resistance of the strain gauge. And in general, we say if you look at the tolerance provided by the manufacturer, that you should be able to install that gauge on a flat surface within that tolerance. Oftentimes for our strain gauges, it'll run anywhere from about 0.3 to about 0.5%.
So, what if I put it into a tight radius? What kind of an effect will that have on the resistance?
Another good question, Tom. And the answer is that it's a little bit unknown. It depends on the size of the gauge relative to that radius. But in general, when you put gauges down inside of a radius, you'll cause the resistance to go down. And it'll really be up to you to decide how much is allowable. You know, you should expect it. How much you'll have will be dictated by the size of the gauge and what that radius is and how much of that gauge goes down in it.
So it comes down to, can my instrument balance it out and use that gauge
Yeah,
appropriately?
that's certainly part of it. You know, can your instrument zero it out? It can also start to influence nonlinearity, although to a small extent. But really, it also has it's like the operator has to decide. And oftentimes it's based off of historical data. You know, if you're commonly putting strain gauges down inside of a radius or a fillet, then you're going to know about what to expect.
So experience helps to figure that out.
Absolutely.
So you said there was a third thing that I need to check to verify the installation.
Right. Well, electrically, there's really two things. One is the installed resistance, and the other is resistance to ground. And a lot of times folks will forget that, just like you did.
I did.
And the resistance to ground is a measure of the conductive path between the strain gauge circuit and the specimen or material that you got it glued onto. And really what you're looking for are any shorts between any of the wires that have maybe gotten stripped back too far. But you're also looking for the presence of something conductive such as flux. And flux is your friend while you're soldering, but it's really your enemy once you're done with soldering. So you got to make sure you clean all that up to ensure the integrity of the gauge installation.
So what's my minimum resistance to ground for a good installation?
Another great question. Typically, we're expecting somewhere in the neighborhood of 10,000 million ohms of resistance, 10,000 megohm. And anything less than that normally means that you need to go back and you need to recheck the installation, maybe re-clean it, and then check it again. And then really you get into the third sort of phase of verifying a gauge installation, which is really checking its performance. So we've optically inspected it. That's phase one. Phase two is to electrically check it. Phase three is check its performance. And we're really looking for three characteristics. Number one is the zero return. So if you can load the structure and then release it, if the structure comes back to its starting point, the gauges should as well. And oftentimes when the gauges aren't bonded well, they'll show some initial non-zero return. That's the first sign.
Are there some non-zero returns like hysteresis of bolted connections? Or that's micro-yielding locally that could affect that? So I got to take care of those things too.
Absolutely, absolutely. The structure may not come back for those reasons. So you have to be aware of that. And you also look for some other signs as well. And those other signs would be repeatability and also how it behaves under a constant load. It should be very stable. So you look for zero return, you look for repeatability, could you put the same load on it 3 times and get the same result? And you also look for how it behaves under a constant load. How does it creep? How does it change with time as you maintain a constant load? And in general, gauges that aren't bonded well, when you put a constant load on them, they really want to go back to their starting point. So they'll start to relax. And if you're watching your data, you'd see it start to decrease. And in general, I'd say anything greater than about 0.5% of full scale would indicate some type of bonding problem.
Okay. So creep is maybe a thick bond line, not thoroughly cured, some other reason why that
Voids.
it's a viscoelastic behavior of the bond line rather than doing what it's supposed to do and transmit the shear right into the gauge.
Absolutely, absolutely. So just to kind of summarize it, optically inspect it, electrically check it, and then check for its performance. And really, if the gauge passes those 3 phases, then I'd say you got a well-bonded strain gauge.
So it's got to look good, it's got to have a good electrical characteristics to it, and then it has to have repeatable and good zero return.
Absolutely.
Thank you, Darryl.
All right.